Today, I would like to discuss how remote sensing data allows both scientists and non-scientists to observe the devastating changes in the landscape of Ukraine caused by war. Yes, the war is taking place on the territory of Ukraine, but any military conflict is not only local when it comes to the environment. Ecosystems cannot be divided by borders simply drawn on a map. If the natural balance in one geolocation is disrupted, then negative consequences will certainly be felt in another. A simple example, the abnormal increase in dolphin mortality off the coast of Turkey, Romania and Bulgaria due to military activities in Ukraine. According to Ukrainian ecologist Ivan Rusev, head of the department of the Tuzla Lagoons National Natural Park, about 3,000 dolphins died in Ukraine during the first year of the war. And a total of 50,000 dolphins died in the Black Sea. There is no doubt that this is connected with active military operations in the northwestern part of the Black Sea. Dolphins died due to the use of high-frequency radar equipment by the military, which stuns and blunts animals as they lost their spatial orientation. Many casualties also occurred due to bombings and hitting mines, including phosphorus mines. This is confirmed by burns on the bodies of some dolphins, which scientists believe could only have been caused by bomb explosions. As a resident of the Black Sea city of Odessa, this news is especially painful for me. However, the consequences of the war are indeed much more severe. The use of geoinformatics for monitoring and analyzing the environmental impacts of conflicts is not new. Historical examples include the application of satellite imagery during the Balkan conflicts in the 90s. For instance, the European Space Agency's satellites were used to monitor the damage to infrastructure and environmental changes. During the Iraq War, satellite imagery was used to track environmental degradation and the destruction of cultural heritage sites. Similarly, during the Syrian civil war, high-resolution satellite images were instrumental in assessing the damage to urban areas and the impact on natural resources. These historical precedents illustrate the value of geoinformatics in providing critical insights into conflict zones. So, Google updates its satellite data by adding new satellite images and improving processing methods. Unfortunately, this doesn't happen very often. For instance, in spring 2023, Google updated satellite images for the first time from 2021. Currently, satellite images from 2022 and some areas of Ukraine from 2023 are available. These images allow us to assess the devastating consequences of the war on urban infrastructure and the landscape of Ukraine. Unfortunately, with Google Images, we can't monitor all changes in real time. We can't know what is happening right now. However, the 2022 images give us a unique opportunity to see and document the tragic events of the early months of the war. I would like to show you satellite images of some of the most affected areas in Ukraine before and after military invasion. The spring of 2022 was especially destructive for the Kyiv, Chernihiv, Kharkiv and Sumy regions, as well as the city of Mariupol. In this slide, you can see how Hostomel airport looked before, during and immediately after the military invasion. The airport has a unique runway size suitable for receiving the heaviest aircraft. The runway was damaged by Ukrainian artillery to make it impossible to transport enemy troops by air. In the March satellite images, burning fuel tanks are visible. The April images show destroyed hangars, craters from ammunition explosions, and abandoned military equipment. Unfortunately, during the battles for the airport, the largest cargo aircraft in the history of world aviation, An-225 Mriya, which was a symbol of Ukrainian aviation, was destroyed. In these satellite images, we can see the breach in the village of Romanivka before and after its destruction. At the beginning of the war, Ukrainian soldiers were forced to blow up the only breach connecting Irpin and Kiev to prevent from capturing Kiev. Later, this site became the only way to save thousands of residents of Irpin, and hundreds of photos of people evacuating were seen around the world. By the end of last year, a new bridge was opened in Irpin. I would like to know that bridges are very important strategic and tactical aspects of the war in Ukraine, deserving of separate study. Ukraine has over 23,000 rivers and more than 28,000 bridges. It's clear that many significant military events and I would even say turning points were connected with bridges. By July 2022, 305 bridges were damaged or destroyed. Some bridges were destroyed to slow down to enemy troops and to prevent them from crossing rivers. Some bridges were destroyed to slow down the supply of Ukrainian troops, like the bridge in the town of Zatoka on the coast west of my home city, Odessa. This bridge was the only direct railway connection between Odessa and Romania. In 2022, it was attacked 3 times and destroyed. Some bridges have become important symbols of the war, like Kerch Bridge. I believe that someday detailed studies will be conducted on how bridges have influenced the course of the war in Ukraine. Satellite images allow us to track the destruction not only of large strategic objects, but also of small villages, of towns. For example, satellite images show how the small village of Moshin, located 30 kilometers northwest of central Kiev, a favorite vacation spot for Kiev residents surrounded by pine trees, was almost reduced to ruins. In March 2022, artillery shelled the village. There were intense street battles in Moshin. The satellite image clearly shows smoke and fires from exploding ammunition. Another heavily affected settlement in the Kiev region is the village of Horinka. The village was bombed in February 2022. Horinka was practically on the front line. The satellite images show many destroyed private houses from space. They look like open boxes. Only the neighboring houses with intact roofs indicate that we actually looking at a street. According to the UN, 70% of the buildings in Horinka were destroyed in the first months of the war. One of the most devastating large cities in Ukraine is Mariupol. Satellite images help us understand the scale of the destruction in Mariupol by comparing the city's condition before and after the siege. A small section of the area shows craters from explosions and destroyed buildings. In the second image, you can see the damage caused by 2 air bombs that hit the drama theater in the city center. The word children, which was written in March 2022 to mark the bomb shelter where Mariupol families were hiding, is also visible. According to an Associated Press estimate, about 600 civilians were killed when the bombs hit the building. Initially, Russia admitted to bombing the theater, but later denied it. And in December 2022, the remaining parts of the theater were demolished. Of course, many more satellite images could be shown to illustrate the destruction and horrific consequences of the war. You can view them yourself using Google Earth. These images remind us that war always brings destruction, pain, suffering, and death. However, let me return to the issue of the negative impact of the war on the environment. My current research project focuses on studying the factors affecting soil degradation in Ukraine. I define degradation as any harmful or undesirable change to land that leads to a reduction in soil quality and fertility. My focus is on the degradation of agricultural lands and the destructive impact of military activities on this process. According to Ukrainian scientists, 33% of Ukrainians' arable land has been affected by military activities and can't be used for agriculture due to the accumulation of sulfuric acid and heavy metals. You can see a satellite image of the section of arable land in Kharkiv region near the city of Izyum. There were 2,052 shell craters in 1 square kilometer. As a result of missile strike and impact of munitions, the organic mineral properties of the soil are completely changed. Because of this, moisture and acidity are decreased and the soil loses its fertility. On the slide, you can see a diagram that demonstrates the mechanism of the impact of ammunition detonation on the environment. As a result of exploding munitions cause chemical reactions that pollute the soil and air and destroy plants. Additionally, burning fuel from military equipment releases uncontrolled emissions into the air, creating substances like soot, sulfuric acid, petroleum, and oxidation products. These can accumulate on the surface of soil, plants, and water. Data from open sources such as maps from the Institute for the Study of War and the Deep State Map resource contain information on troop movements. This map shows the location of numerous fortifications built along the front line, which can cause landslides, flooding, soil subsidence, and similar problems. The movement of heavy equipment compacts the soil, reducing its ability to absorb water and making it more prone to erosion. The formation of craters from explosions disrupts the air-water balance in the soil. During the war, a significant part of Ukraine was mined. According to the Prime Minister of Ukraine, as of the summer of 2022, 250,000 square kilometers were mined. In my personal opinion, this number may be overstated as it represents about 40% of Ukraine's total area. Additionally, some areas have already been cleared of mines. In addition to the direct physical and chemical impact of the soil, military activities have broader environmental consequences. For extensive use of explosives and the movement of military equipment not only change the physical structure of the soil, but also disrupt the habitats of many plant and animal species. The destruction of vegetation, whether through direct mechanical impact or through the indirect effects of pollution and changed water regimes, leads to a loss of biodiversity. Soil and water pollution by heavy metals and other toxic substances creates long-term risk risks to human health and agricultural productivity. These pollutants can enter the food chain through crops and livestock, leading to bioaccumulation and potential health hazards for the local population. The loss of arable land and reduced agricultural productivity threaten food security not only for Ukraine but also for regions that depend on its agricultural exports. Another example of the negative impact of the war on the environment is the destruction of the Kakhovka hydroelectric power plant. The dam provided annual regulation of the Dnipro River flow, irrigation and water supply to the arid regions of southern Ukraine, as well as navigation of the Dnipro from Kherson and Zaporizhia. The dam was also strategically important because it connected the right and left banks of the Dnipro with road and railway bridges. The Russians captured the Kakhovka hydroelectric power plant in February 2022, and last summer it was blown up just as Ukraine was beginning its military activity in the south. Powerful explosions destroyed both the station's machine hall and a significant part of the dam. The Kakhovka reservoir ceased to exist. The released waters of the Dnipro rapidly flooded numerous villages and towns downstream on both sides of the river. Around 80 settlements, including the city of Kherson, were inundated. The flooding devastated over 11,000 hectares of forest land and damaged natural habitats, resulting in the chemical pollution in those areas. Tens of thousands of Ukrainians had to leave their homes to escape the danger. The scale of the consequences made the destruction of the dam one of the most serious acts of ecocide. The Criminal Code of Ukraine defines ecocide as mass destruction of plant or animal life, poisoning of the atmosphere or water resources, and other actions that may lead to an ecological catastrophe. The destruction of the power plant had a catastrophic effect on the ecosystems and biodiversity of southern Ukraine. The sudden loss of water from the large reservoir caused many fish and animals to die, flooded the dry lands, and changed the climate regime of the region. The crime committed also hard farming in the area. The channel used to supply water to 1.5 million hectares of land in southern Ukraine, including more than 30 field irrigation systems in the Dnipro, Kherson and Zaporizhia regions. Now where the Kakhovka reservoir used to be has become a forest. The shore is covered with shells, and willow trees have grown on the dry ground, filling the space where the reservoir once was. Large-scale fires caused by military actions also have a huge negative impact on the environment. Burning vegetation and buildings release significant amounts of harmful substances into the atmosphere, polluting the air. The resulting smoke and ash can fall on the soil and water bodies, introducing additional pollutants and changing the chemical composition of these environments. Geographic informational systems allow us to analyze the distribution of fire points during wartime. For this, data from NASA's fire observations can be used. The Fire Information for Resource Management System, or FIRMS, provides active data from the different radiometers on the Aqua, Terra and GPS-S1 satellites. The data is available for Ukraine for download on the official firm's website from 2005 to the present. This slide visualizes archival information about fires in Ukraine during wartime obtained from NASA's film system. The location of fires are marked for 4 periods, the first and second half of 2022 and the first and second half of 2023. The maps show that fire hotspots correlate with military activities. For example, in the first half of 2022, there was a high concentration of fire hotspots in the north and west of the country. During this period, there were battles in the Kiev and Kharkiv regions. Western Ukraine was subject to missile attacks. In the second half of the year, the number of fires increased in the south and east as military operations shifted from the Kiev and Kharkiv region to the south, including Mariupol, Melitopol and Kherson. In the first half of 2023, the number of fires was almost 3 times lower than in other periods. This was a time when both sides of the conflict were building up their forces. Ukraine faced a shortage of ammunition. In the second half of 2023, the number of fires along the front line increased sharply. To identify various anomalies in the distribution of fire points during wartime, a good approach is to compare the pre-war and wartime periods. For this, a time series from 2008 to 2024 was used, which was divided into pre-war and wartime periods. First, the data was aggregated monthly to obtain the number of fires per month. The chart shows that the number of fires slightly decreased during the war years, especially compared to the period from 2014 to 2018, when the active phase of the first war in eastern Ukraine was happening. The number of fires decreased almost threefold. This is an interesting fact that requires further investigation. The same trend is shown by the annual distribution of fires over the analyzed period. The analysis of fire data shows a seasonal pattern. During winter, there are few fires, but with the arrival of spring, the number of fires increases sharply, peaking in March and April, and then drops back to winter levels in May and June. Another peak occurs in August, followed by a small decrease in September and rise again in October, after which fires decrease. This seasonality is linked to the burning of dry grass in fields, which often leads to uncontrolled fires. In July-August, extreme heat also causes more forest and pit fires. Overall, the monthly distribution of fires in 2022 and 2023 follows this seasonal pattern, but there are some unusual deviations that didn't observe in previous years. In 2022, nearly half of the fires for the whole year happened in March and April. In 2023, almost 60% of all fires happened in August and September, and the usual March and April peak is hardly present. In almost all pre-war years, there were 2 clear peaks in March, April, and August. It's also notable that the number of fires in May and June nearly doubled. For my research, I create 2 heat maps of fires in Ukraine. one for the period before the war and one for the period during the war. From 2008 to 2021, the heat map shows that fire hotspots were evenly distributed across the territory of Ukraine. A large number of these hotspots were concentrated around major industrial facilities. The main causes of these fires included high temperature from industrial processes, industrial emissions, technical malfunctions, and schedule waste burnings. Significant hotspots were observed near plants such as Azovstal, Nikopol ferroalloy plant, Pabursky ferronickel plant, and others. In contrast, the heat map of fire from 2022 to 2024 during the war reveals a different pattern. The primary hotspots are now concentrated along the front line. This shift indicates the significant impact of military activities on the distribution of fires. Moreover, there are clear traces of fires along the road taken by Russian troops in early 2022 from the Belarusian border to Kiev. A significant number of fires are also recorded in the Kherson regions and other areas of Ukraine where such activity was not observed in the previous 10 years. These two heat maps illustrate how the source and the locations of fires have changed due to the ongoing conflict. Data from NASA's firms has been crucial in visualizing and understanding these changes. To find areas with the most fires and potential risk of land degradation, the local indicators of spatial association or LISA method was used. This tool helps identify significant clusters like zones with high or low concentration of fires. The input data for this tool includes polygons and the number of fires in each of them. During data aggregation, a hexagonal grid was used. This method is popular in spatial analysis because it distributes data more evenly, as hexagonal grid has good symmetry. The hexagon size is 2 kilometers. When we applied this tool to the fire data, we found that the fires show moderate spatial autocorrelation overall, highlighting specific areas with clusters of values. They are called hotspots. It's clear that the spatial distribution of these hotspots aligns with the front line. We can then overlay these hot clusters on a cadastral map of agricultural lands to identify those most at risk of degradation from fires. In summary, various GIS tools and satellite monitoring data are very useful for different tasks, like analyzing the impact of war and the other environmental challenges. Concluding this lecture, it's important to highlight once again that the war in Ukraine has deeply affected the environment in many ways. Soil and water quality have degraded. Ecosystems have been destroyed, and there are long-term risks to human health and food security. This situation shows the urgent need for detailed environmental monitoring and restoration efforts. Geoinformatics and remote sensing technologies play a crucial role in assessing and reducing these impacts, providing valuable data to support various decisions and management plans. Special attention must be given to the environmental consequences of military actions which cross borders and affect ecosystems and communities beyond the conflict zone. Military activities harm plants and animals and contribute to air and water pollution, highlighting the global nature of environmental issues linked to war. The high mortality rate of dolphins in the Black Sea due to military actions serves as a reminder that the environmental consequences of war extend far beyond the conflict zones. These examples of catastrophic destruction highlight the interconnectedness of human and ecological systems, illustrating the importance of protection and preserving natural resources during both peace and war. Thank you for your attention.